Well, hi there. This is Arlissa from 8-Minute Maths, and we are going to talk in this video about using exponents in your college algebra class. I want to start off first by reviewing the rules that go along with exponents. And you have, let's say, a to the third power times a to the fourth power. Using the product rule gives us a to the 3 plus 4, or a to the 7th power. Second one is called the quotient rule. The quotient rule says x to the 5th power divided by x to the 2nd, or any quotient with the same base, you subtract the exponent. So this is x to the 5 minus 2, which is x to the 3rd power. Third rule is called the power rule, and it's when you take x to the 3rd power and you raise it to the 2nd power. When in this situation you multiply the exponents, and this is x to the 6th power. Okay, number 4, let's do the fourth one. This is going to go through all these. This is called the zero rule. Anything raised to the 0 power equals 1. Doesn't matter what it is. If it's raised to the 0 power, it equals 1. Number 5, the negative exponent. X to the negative 4. Anytime you have a negative exponent, the base and the exponent change place in the fraction and they become positive. Because this is x to the negative 4, like over an invisible 1, then this would change places in the fraction and become positive. So like 1 over x to the negative 3 is the same as x to the 3rd power. This x to the negative 3 would go to the numerator and the exponent becomes positive. This is the power of a product. Says that anything inside the parentheses, when it's raised to a power, that means everything must be raised to that same power. So x, because it has an invisible 1 up here, invisible 1 right here. 1 times 3 would be 3. 1 times 3 would be 3. So x cubed, y cubed would be the answer there. Now we have a quotient raised to a power. If x over y raised to the 4th power means that everything inside of this parentheses also has to be raised to the 4th power. Last but not least, we're doing the negative exponent of a quotient. Let's say x over y, parentheses to the negative 2. Well, this would be x to the negative 2 over y to the negative 2. And because we always want to have positive exponents, this now, the x to the negative 2 needs to go to the denominator and become positive. Y to the negative 2 in the denominator goes to the numerator and becomes positive as well. So that is the 8 rules that go along with working with exponents. Now we're going to take these 8 rules and put them to use in more complex problems. Say, for example, 1, we have p to the 4th power times p to the negative 7th power. Well, there's 2 ways you can do this. Our rule says that anytime you multiply the bases, then you add the exponent. So this would be p to the 4 plus a negative 7. Well, 4 plus a negative 7 is p to the negative 3. Following our rule up here, p to the negative 3 is the same as 1 over p cubed. Another way we could have done this problem, I'm going to do here like a method 2. Another way we could have solved this same problem, or simplified, not really solved it, simplified this same problem, was to keep the p to the 4th, but the p to the negative 7, because it's negative, automatically moves to the denominator. and becomes positive. So if you have 4 p's up here, this is just like 4 p's, and this is like 7, 4, 5, 6, 7. So now we're reducing, simplifying here, all these p's, and what's left up here is just 1. This would give us 1 over p to the third power also. We get to the same place. All depends on how you want to go about getting there. I'm a big fan of putting things into the positive location as early as possible and then simplifying from there. That's just my preference, because that way I can make sure things are where they're supposed to be going. Example 2, we've got negative 3xy to the second power. All of this is being raised to the second power. Remember, I told you for the power of a product, it means that everything in this parentheses also needs to be raised to the second power. So the negative 3 to the second power, the x to the second power, the y to the second power. Negative 3 squared is 9, x to the second power, x squared, y to the second power, y squared. This is the simplification of that problem. Example 3, we have 5x raised to the 0 power. Do we remember our 0 power rule? It's that anything raised to the 0 power equals 1. That whole thing equals 1 because it's raised to the 0 power. Let's move on to example 4. Example 4, we've got p over 2 raised to the 5th power. Well, we've got a quotient that is raised to a power. So p to the 5th and 2 to the 5th. Anytime you have numbers, you do want to go ahead and expand them out. Don't leave them as an exponent. You can leave the variables as exponents, but with the numbers, you want to go ahead and multiply those out. So 2 to the 5th power, I believe, is 32. 2 times 2 is 4. 4 times 4 is 16. Times 2 more, 32. Yes. Okay. Example 5. We've got x cubed y over z to the 4th power, all raised to the 2nd power. Getting a little more involved here. Remember, everything in the parentheses must be raised to the 2nd power. So we have x cubed raised to the 2nd power. We have y raised to the 2nd power. We have z to the 4th raised to the 2nd power. So remember, when we raise something to a power, we multiply these exponents. So this is 3 times 2. This is just going to be y squared. Z to the 4 times 2. This gives us x to the 6th, y squared over z to the 8th. We took each of these terms, raise it to the 2nd power. Multiply, when you raise an exponent to a power, you multiply it. 3x to the 3rd power squared is x to the 6th, y squared. Z to the 4th power raised to the 2nd is z to the 8th power. Example 6, getting a little more involved here. Over 2c to the 4th, all raised to the negative 3. Let's take a little look at that. 5a cubed b to the negative 1 over 2c to the 4th, all raised to the negative 3rd power. What do we want to do first? Do we want to get everything in the positive exponents and then move things? Or do we want to apply the negative 3 to everything right off from the beginning? I don't know. Let's do it both ways. So this is going to be 5 raised to the negative third power, a cubed raised to the negative third power, b to the negative 1 raised to the negative third power, over 2 to the negative 3, put some parentheses around this, and c to the fourth, all raised to the negative third power. Notice how everything in here, the negative 3 applied to everything inside the parentheses. Okay, I'm going to go ahead and put me an fraction line in here. Let's move things around. 5 to the negative third power is going to go into the denominator and become 5 to the positive 3. I like to cross things off as I do them. That way I know I've done it. A to the 3 raised to the negative third power. I'm going to go ahead and write this up here just so I don't forget that that's what happened. B to the negative 1 raised to the negative 3 is b to the third power. In the denominator, 2 to the negative 3, I think I can go ahead and move that. I already took care of these. I can go ahead and move this to the numerator, 2 to the positive 3. Remember, when it changes place in the fraction, the exponent becomes positive. And then we have c to the negative 12. Now we have some things that are positives and some things that are negative. So I'm going to go ahead and get everything positive. 2 cubed. B cubed stays up here. A to the 9th is going to move to the denominator. 5 cubed is already down here. And c to the negative 12 moves to the numerator and becomes c to the positive 12. See what we have. 2 to the third power. 2 times 2 is 4. Times 2 more is 8. B to the third power. C to the 12th power. Over 5 times 5 is 25. Times 5 more is 125. A to the 9th power. It's a long way to go from here to here. But you notice how we took it step by step. First, we applied the negative 3 to all of the terms. Then we applied that negative 3. The whatever negative exponents we had, we moved them around. So a to the negative 9 went to the denominator and became a to the 9th. C to the negative 12 in the denominator went to the numerator and became c to the positive 12. We shifted the 5 to the negative 3 to the denominator and 2 to the negative 3 up to the numerator. Okay. And when we were all said and done, we expanded the numbers as we were supposed to and left the variables with the exponents in the positive form so we could get a good solid answer. Okay, our last example here, this one's going to be a doozy. 2xy squared over x cubed y to the negative 2, parentheses, squared, times 12xy cubed over x cubed y to the negative 1, all to the negative 1. So let's reduce what's inside the parentheses first. Let's reduce what's inside the parentheses first. So this is x to the invisible 1 power up here. I'm putting a 1 there. It's the invisible 1. And x cubed down here. If we were to simplify, this would go away and this would become x squared. We have y squared and y to the negative 2. So this is going to go to the numerator and become y squared. So what we have up here now, I'm going to go this way. We have 2 in the numerator, 2y to the 4th over x squared raised to the 2nd power. Now let's look at what's happening in the second parentheses. Our 12 stays there untouched. We can reduce our x's here. This is another invisible one, so we can reduce this. This becomes x squared. The y to the negative 1, this is going to move to the numerator and become y to the positive 1. So here we have 12 y to the 4th again over x squared, but this is raised to the negative 1. So now let's go ahead and apply these exponents, the outside powers. So this is going to be 2 squared times y to the 4th squared over x squared squared times 12 to the negative 1 y to the 4th raised to the negative 1 over x squared raised to the negative 1. Close parentheses. Looking at the first one, we got 2 squared is 4. Y to the 4th raised to the 2nd power is y to the 8th power. X squared squared is x to the 4th power times 12 to the negative 1. Well, this moves the 12 to the denominator and becomes a positive 1. Y to the 4th to the negative 1 is y to the negative 4. So we move it here and it becomes positive 4. X squared raised to the negative 1 is x to the negative 2. That can move to the numerator and be x squared. Now we're ready to reduce things. We can reduce in place. Let's look at the 4 and the 12. 4 goes into 4 once. 4 goes into 12 3 times. We've got x squared and x to the 4th. This is going to go away. This becomes x squared. We've got y to the 4th, y to the 8th. This goes away. Well, it becomes 1. I say goes away. And this becomes y to the 4th. So now looking across the numerator, we've got just y to the 4th. Because the 4 was reduced, the y to the 8th was reduced to y to the 4th, and the x squared was reduced to 1. So that's y to the 4th in the numerator. And here we have x squared. We have a 3 left. Let's put our number in the front. We have x squared left. After we reduce this x squared and x to the 4th, we have x to the squared left. And y to the 4th was reduced down to 1. So our answer then is y to the 4th over 3x squared. Okay, so we've covered about 7 examples plus all the rules that had to go along with exponents. When you go to your college algebra class, your professor is going to expect that you know these rules of exponents. Your college professor is going to expect that you know these rules. This is probably not going to be taught. The teacher may go over it, but it's not going to be anything that the teacher spends a whole lot of time on, because they're definitely going to assume that you already know these rules when you come to college algebra. Okay? Like I said, this is our Alyssa with 8-Minute Maths. This month we are running a special on the Algebra Survival Kit. And why do we have an Algebra Survival Kit? Well, the Survival Kit is a resource that is 100% gets you completely ready for your algebra class. It gives you everything you need to pass your college algebra class. It includes the prerequisite things like those exponent rules I was talking about. It includes working with rational numbers, integers, solving equations, solving inequalities. It goes into function, system of equations, polynomials, factoring, working with multiplying, adding, subtracting, dividing polynomials. I mean, all that is in this Algebra Survival Kit. It is a full and total resource. Part of it is videos. Part of it is a lesson with practice problems and solutions that are worked out. There's also quizzes and tests associated with it. So that way you can get everything that you need. Alrighty. Look for us on YouTube at Arlissa Pinkleton 8-Minute Math. Look for us on LinkedIn, Arlissa Pinkleton 8-Minute Math. Look for us on Facebook at 8-Minute Math Help. Okay, so we have a group there for support of those who have returned to college and have math issues. And of course, you can go to our website at 8minutemath.com. There's a blog there, lots of good information, tips and tools. Basically, we're everywhere. And the Algebra Survival Kit for this month is $50. It is on sale for this month and will go back to its regular price of $88 on March the 1st. All right. In our next video, we will talk about exponents and polynomials. So look forward to seeing you there. Come check us out. All right. Bye. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemath.com, where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathhelp.com. We look forward to seeing you there.